This is Frederick Pearson doing Lab 2, Population Ecology. I'm in Environmental Science 1401 online course for fall 2018. Number one of the ecology lab, we are to video ourselves, as you see I'm doing now. Number two, we're supposed to put 4 to 6 large handfuls of beans into a large bowl. Also done that prior to the uh, taping. Then I was requested to remove 1 handful of beans from the bowl. I've done so. 1 handful of beans, each one marked red. There was 113 beans that I pulled out in 1 handful. Now I'm going to return these back to the bowl as instructed. Now I guesstimated that there's probably about 450 to 500 beans in the bowl. So I put 450 as my estimate. I'm going to shake them up. I'm looking at it. And I'm going to pull another handful. As you can see, I have removed another handful of beans, some marked, some not. The question states that I'm to shake the pitcher and without looking grab another handful of beans. This is my second trapping. This is my second trapping sample. I'm to count how many I pulled out total. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 52, 54, 56, 58, 70, 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, 92, 94, 96, 98, 100, 102 on my second trapping. I'm marking that down on number 5. Then it says to how many beans, whatever in your second trapping sample, were already marked. I will check that now. Have patience with me. There's a lot of beans here, and they're very small, so they're hard for me to handle with my hands. I have to check each and every bean, so that's 102 beans that I have to check to make sure there's no marks on them. One moment, please. I'm still counting and looking. I have to make sure I get all the marked beans out so I get an exact total so that this lab goes off correctly. Little bitty beans with big old hands. Sorry, ladies and gentlemen, for this long wait. There's a lot of little bitty beans, and each one's individually marked. So I have to check the ones that are and the ones that are not. Okay, ladies and gentlemen, after separating the beans, I count 2, 4, 6, 8, 10, 12, 13 beans. That's 13 marked beans out of 102 that was marked. Now I'm supposed to use the equation. Large case N over small case m equals small case n over small case m. Now I'm going to do the equation above to calculate my population. Now, the uppercase N is my population estimate, which I figured 450. Then it goes under the number of animals captured and marked in the first sample, which was 113. And then the number of animals captured in the second sample, which was 13, and the number that were already marked. I'm sorry, captured in the second sample was 102, and captured was 13. Now, if I do the math here, it should come out correctly. Let's see. 113 into 450. 450 divided by 113 equals 3.98. So we're going to estimate 4. Well, I'm going to do it the exact way. I'm going to put 398. 3.98. Now, on my second sample, supposed to be 102. Okay, let's see. Number of captured. 13. 102. That's 13 divided by 102 equals 0.127. I don't know if I done this incorrectly or what, but I get 3.98. Let's do this one more time to make sure. It says the large N is the population estimate that I put in the first time, which was 450. Then the large M is the number of animals captured and marked in the first sample, which was 113. Then it says equals, then the small n is number of animals captured in second sample, which was 13, and small m, number of n that was already marked. Okay, that's what I did wrong. I reversed the 2. Should have been 102 over 13. So let me correct this. So that's 102 divided by 13 equals 7.84. Okay, my number 9 question is, was your estimate using the ratio closer than your initial guess? I'm not real sure. If I'm going by the mathematics here, N is supposed to be my population estimate, which is 450. M is the number that captured the first sample, which is 113. Those were the 113 that are marked. That gave me 3.18. Once again, 450 divided by 113, which was my first sample. That gave me 3.98. Now it says the count. I'm sorry, that's 3.98. Equation above calculates population estimate. If this equation's right, I'm coming out with a different number. A 3.98 on one side, 7.84 on the other. To me, that's nowhere near my estimate. My estimate was 450 beans. It says count the actual number of beans, whatever is in your box, altogether. I will be back in a moment and give you the answer to that. Give me 1 second. Okay, I've counted all the beans that were in the bucket, and there are 621 beans total in the bucket. Now, was my estimate using the ratio closer than your initial guess? Well, if I go by the 450 equals 102, that's 5. Yes, it is closer. How could I increase the accuracy of my estimate? I do more trappings in between and mark or capture more animals so that I get a closer estimate each time. Capture and release more animals or more beans and release more until I get a closer estimate over time. It says, what species of animal would this technique work well for? I would say it would work well for things such as like penguins, large groups, fish, even some birds. The ones that won't work for, that I don't think it will work for, would be things like wild animal, extremely energetic or wild animals that you can't capture very easily, such as ants or a species that is that's small in size. Can you think of a better way to estimate the number of beans in the box? No, not really. Not unless I do multiple catch and releases until I've gotten a more accurate term of how many beans are in the box. Thank you. This is my lab 2, Population Ecology. Frederick Pearson.